Okay, the second fundamental theorem of calculus. Okay, various textbooks will call this the first fundamental theorem of calculus. Some, like ours, will call it the second fundamental theorem of calculus. And I have a slightly different way to write this theorem than a lot of the textbooks do. And I got this when I took the course as a refresher. When I took Calc 2 a second time as a refresher. So I write it like this. Okay, so that's how I write it, and I think it'll make more sense if you see how it's applied. Okay, so let's say I want to find the derivative of f of x. So it's f prime of x, and remember this means the antiderivative. Okay, so I would write that d dx times the integral from pi over 2 to x cubed of cosine of t dt. Okay, let me put a bracket around it. So I want to take the derivative of the integral, which is then taking the derivative of the antiderivative, so I basically get the original function back, is what this says. It shows, this theorem shows how integrals and derivatives undo each other, right? So basically I get this. I get cosine of x cubed times the derivative of that, which will be 3x squared, minus cosine of pi over 2 times the derivative of pi over 2, which is 0. So this whole term is 0. So I get 3x squared cosine of x cubed. Okay? As long as this is a constant, you're always going to get 0 for the second term, which is why a lot of textbooks will write this theorem like this. A being a constant to x of f of t dt is equal to f of x. And you can kind of prove to yourself, if you take the antiderivative of f of t and plug in x and plug in a, then take the derivative of that, you're going to get f of x. My expression of this theorem gives a little more clarity what to do with more complicated versions of it. Okay, so let's try another problem. Okay, so I want to evaluate this. So I get the original function back times the derivative of the inside minus plugging in zero and times derivative of 0, which is a constant, is just 0. So this whole thing is 0. So I just get x squared plus 1. So that kind of obeys the theorem that you see in a lot of textbooks. Okay, and again, I don't think that lets you do every problem, but it's fine. All right, let's look at another example. Okay, so I get x squared to the 4th times derivative of x squared minus 2x to the 4th times derivative of that, which is 2. So I get x to the 8th times 2x minus 16 x to the 4th times 2. So I get 2x to the 9th minus 32x to the 4th. And that's it. you'll just need to have some practice applying it. It's really not too bad, but it looks a little mystical when you first encounter it. I remember having that feeling. Alright, good luck.